Okay, so we are doing U11.RSP1. So Unit 11 on resistors in series and in parallel. The problem we're doing is to calculate the equivalent resistance for a circuit of resistors in series and find the current in and potential across each resistor in the circuit. So right here I have a nice sample problem. It says a series combination of two resistors, 7.25 ohms and 4.03 ohms, is connected to a 9-volt battery. What is the equivalent resistance of the circuit and the current? What is the potential difference across each resistor? So first we're going to draw this problem. This is going to be resistor 1, and we're going to give it the 7.25 ohms. This is going to be resistor 2, and it's going to be 4.03 ohms. Now, when resistors are connected in series, like these, all you have to do is add up each of the resistors to find the equivalent resistance. So to find the equivalent resistance, we just add 7.25 ohms plus 4.03 ohms. When you add 7.25 ohms plus 4.03 ohms, you get 11.28 ohms. And that is the equivalent resistance. Now, to find the current of the combination, you have to use the equation that total voltage equals total current times the equivalent resistance. Well, we know this battery had a voltage of 9 voltage, because that's what it said in the problem. So, we can do 9 volts equals I, since we don't know the current, times 11.28 ohms, because that's the equivalent resistance. Now we divide this by 11.28 ohms, divide this by 11.28 ohms, and we get the current equals 0.798 amperes. Now, to find the voltage or the potential difference across each resistor, we must times the current, because the current, when connected in series, is the same in each resistor. So we must times voltage equals the current in R1 and R2 times the resistor of R1, or the voltage equals the current in R2 times the resistor in R2. So to do that, we do V equals 0.798 times 7.25 ohms, and we get 5.78 volts. When we do voltage equals 0.798 times 4.03 ohms, we get 3.22 volts. And there you have it. That is the potential difference or voltage, the current, and the equivalent resistance of a series combination.